Welcome back, everyone. Today, in this CAM training, we're going to be covering the order of operations. So essentially, how you need to use different tools and different types of operations in order to go from a stock to a final product. So, as you can see here, we're using the typical Auburn CNC router and CAM certification piece, again, because Auburn Makerspace. And I already have everything populated here that we would need for either the CAM or the router certification. It's going to remove all the material. It's going to use different tools. And so we're going to kind of go step by step through this, and I'm going to talk you through why I have chosen each of these types of operations and why I've chosen the tools that I did for them. So first things first, we can see our setup is here. We have our stock in the dimensions that I will give it to you for the router certification. You have your coordinate system, X going this way, Y going this way, and Z going up in the bottom left corner on the bottom of the stock. Next, we're going to go ahead and take a look at this first operation. So this is an adaptive. This is what we would call a roughing operation. So typically, we like to start with roughing operations because it allows us to remove the most amount of material in the most effective and efficient manner. And so essentially, we're starting off with this big chunk of wood, and we want to remove, all of this material here and all the material inside the pocket and on the outer edge. And so the best thing that the best way to do that is to start off by using a roughing operation. And so adaptives and pockets are both roughing operations. You can see here that there's a line separating them from all of these other different types of operations in 3D, and then the same for 2D, you can see right here. So we have 2D adaptives and pockets and 3D adaptives and pockets. So we're going to start off with a 3D adaptive and pocket because I want to move along the Z dimension as well. That way I can take multiple steps as I kind of go down. That's very advantageous for this piece because we have this contour that we want to hit, and we'd like to remove a lot of material there before we go in with a ball end mill and finish it, but we'll get to that later. So notice that a lot of material has been removed by this adaptive. We're using a 1/2 inch end mill, you can see right here. But if I go in and simulate this, you can kind of see how quickly we're removing that material. You can see the percent of stock removed, and it's really just chewing away at it. And so an adaptive is essentially going to figure out the best way to remove that material. And so, it's kind of doing some funky things here, but according to Fusion, this is the most efficient way to remove that material. So we're going to go ahead and X out of the simulation, and we'll move on to the next operation, which is a flat. Now, some people would disagree with me here on having a flat in this location. Typically, flats are something you do at the very beginning to get your stock flat, or something you do at the end as like a finishing operation. The reason that I have chosen to put the flat here, it is a finishing operation in this case. So it's going to leave a final surface finish on all of these surfaces that we're hitting. The reason I've chosen to place it here is because we have this large radius 1/2 inch end mill. So this is the biggest radius end mill that we're going to be using. You typically step down in size as you continue to machine in radius size of the end mill, that is. And so I want to be able to cover as much surface area as possible, as quickly as possible. And you can do that most efficiently with a large diameter end mill. And so that's why I'm hitting this operation now. Some people like to move it to the end. I just like doing it when this tool is already in the machine, so I can post both of these at once for the Laguna, which is the CNC router that we'll be using for the certification piece. So I hit this flat, and then I go ahead and machine all of these lines and take the axial dimension, which is this, the Z component dimension, down to its final measurement. And so there's 0 stock remaining for the Z height. So I do that. Next, we've kind of done everything we can with this 1/2 inch end mill. Like if you'll notice, like the 1/2 inch end mill, when we do the adaptive, isn't going to machine in this area right here just because it can't fit. And then there's a lot of stock that's left to be removed here and here. And so we need to go down to a smaller sized end mill in order to get that. And so we're going to switch to our 1/4 inch end mill. You can see the diameter is smaller, and it's going to automatically pick up with a pocketing operation all of these areas that need to be machined. And so I actually went in and selected the geometry. So you can see here that when you go to geometry, you can actually use face contours, or you can bound it using all of these different all of these different selections to bound the machining. And so I've selected these two pockets, and then it came in and it machined them. As you can see, there's still material that needs to be removed here. And so after that 1/4 inch end mill, we're going to go ahead and switch again to an even smaller diameter end mill and remove more material. So you can obviously see we have a pretty decent amount of material that needs to be removed here. And we switch to our smaller 1/8 inch end mill, and we actually get the ability to machine those internal corners. One big thing for design that I'll just go ahead and mention is if you have sharp internal corners, we don't have an infinitely small radius tool. Unless you're talking about an engraving tool, which technically still does have a small radius at the tip, you are not going to be able to machine perfectly sharp internal corners. And that's why, if you notice here, none of these corners are perfectly sharp. They have a radius, and the radius is actually an 1/8 inch radius. That way we can, hit it with this tool. Anyways, I divulged a little bit, but essentially we're doing a pocketing operation here with our 1/8 inch end mill, and then we're going to go ahead and move it to a contour operation, and that is going to take the radial dimension down to what it needs to be for the piece. So now we have removed all of the stock from the radial dimension just by going in and selecting this contour. You'll notice that the blue machining lines turn yellow for these internal corners. That is what we call feed optimization, and I'll get into that in a later lecture. But essentially what we're doing here is slowing it down for the internal corner. That way we don't accidentally overshoot here. Like I said, we'll learn about that later. But we're taking this 2D contour with an 1/8 inch end mill, which means that we can hit all of these rounded internal corners, here, 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 these three here. And that's going to take our radial dimension down to size. And lastly, you'll notice that we have this 45-degree angle chamfer along the outside of the A. Well, right now it doesn't look very good. The adaptive has left some very rough steps here that we need to take care of, and we can do that with this 3D contouring operation. So we're going to be using a ball end mill. Typically, anytime you want to do a 3D contour, you want something that has very small engagement. That way you can get, obviously we're engaging right here, and so we can get a nice smooth contour, whereas if we had a flat end mill and we were trying to engage, we just have one little tiny point we can engage with, and it's not going to work too well. So we're going to use that ball end mill. We're going to get better tool engagement on the contour, and it's just going to look prettier. If you'll notice, there are some tiny little cusps, but they're very hard to feel with your hand. You can actually adjust the cusp height. So if you go over here to passes, somewhere around here, cusp height. So we have it set at 5/10,000ths of an inch, which means that this cusp is only sticking up 5/10,000ths of an inch. So it's very small. You can actually get it to where you don't need to do any sanding when the piece comes off of the machine, which is my favorite part about CNC routing. So that kind of covers everything for this video. We have gone through the different types of tools, how we're going to step down in diameter in order to most efficiently machine. We have covered roughing operations. We've covered finishing operations like this contour, and then our flats. And if you guys have any questions, feel free to reach out. But I will see you guys in the next video. All right, thank you.